Let's see the demo scope for today. We want to live migrate a WordPress app which is running on a VM on a GPE environment directly to a container running on Kubernetes using Migrate for Anthos. Now, the reason we chose this application is it's not a simple application. It's not a very complex application at the same time. It has got a PHP server. It has got a MySQL database in the backend, so we can also see how data can be migrated along with the application itself. We'll discuss on the limitations and requirements for Anthos, and also discuss on what apps are great fit for Migrate for Anthos. Now let's come back to the topic of discussion at hand. So we wanted to migrate a brownfield legacy application to a cloud native platform like Kubernetes. So what are the challenges because of which it's very hard to do this today? The team which has made this application, which maybe 5, 7, 10 years back, is no longer there. The lack of knowledge or confidence and fear of breaking things prevent people to go and break open the application. It's a COTS or ISV application, which means you do not have the source code. It's managed by some other organization. It's too much risky, time-consuming, and resource-intensive to go back to design board, find the market context, run into design, or do a TDD and ATTD kind of testing frameworks. It's basically running an SDLC process to finding out properly doing that microservices architecture is quite hard. So another reason is that if you do a cost benefit analysis, you will find that the end of life of this product may be there in 2 years or 3 years time. So instead of really going and redeveloping or rewriting the application, can we find a middle ground in which we can extend the life of this application by improving the operational efficiencies and the environment in which this application resides in the cloud? That is the right fit to migrate directly to a cloud native environment using a tool support, of course, instead of rewriting those applications.
First thing that we need is a source. Now, a VM source, right? So let's go to the marketplace within Google Cloud. Now, this is a place where it's home to all paid and free solutions which are packaged as a deployment manager, which is a Python Jinja template. So let's find a WordPress app. So WordPress, I'm going to pick click to deploy. So the best part of the marketplace is these are solutions that you can deploy in a single click, literally. So I'll choose the multi-site WordPress. Okay, and just go ahead and launch. That it allows me to configure the VM if I want. I can choose a higher size t-shirt sizes. But for now, I'll just pick up the default. One thing which is very, very important to note here is the persistent disk and the 10 GB boot disk size. Now, please keep a note of this because we will revisit this when it would have converted this storage, which is used by the MySQL database of the WordPress, into a persistent volume in the Kubernetes language. So that's pretty much it. Let's go ahead and deploy the application. You will see that the scripted, the Jinja templates, it goes ahead and executes it. Literally, I had to do one click to deploy this entire WordPress as a VM form factor. But the interesting thing is that we are going to go and convert this application into a containerized form. And you can see that the WordPress application is deployed. I have got a public URL for this one. Let's go ahead and click on the URL, and the application is deployed. So literally one click. And what I also have is the username and password, just in case if I need to log in into the system. So while my source is now ready, let's go back and revisit a configuration, and let's go ahead and add the source. So again, I have to choose the processing cluster. Go ahead here. We'll call it as M for a demo. And yeah, so this is very important again. The source types today, what we support is GCE, VMware, AWS, and Azure. So effectively, x86 Linux environments is that we support. So if you are on IBM AIX servers or Solaris or any of those Unix systems, so you can be in contact with us, and we will see how best to support this. But for today, M4A does not support those non-Linux, non-x86 environments. We'll go ahead and take the default values for them, the service account, and let's click and let's add source. Okay, looks like the migration is created now. So we're done with the processing cluster, the sources, and now the main thing is the migration source. Now let's go ahead and click the migration source. Here I'll call it Anthos A demo again. Source. So the source cluster that we had, sorry, the source VM that we had chosen. I will also need to give the VM ID for this one. So let me go back and grab the VM ID. So the VM ID, I believe, is this one. Yes, the instance ID is this one. So let me grab that one and enter it here. Now again, here I've got three options that what is my intended migration. Am I only looking for an application migration? Am I looking for only the data migration? That means the persistent disk that we talked about. Or am I looking for both application and data? Now, in my case, I need both of them, so I'll go ahead and choose this option. And that's it. I'll go and create the migration. Once the migration is created, you will see the status coming up here. Okay, so what it says is, if there is an error here, so what it says is the VM should be stopped during the process of disk snapshot. So since it is a live application now and it takes a snapshot, what we need to do is go here and stop the VM for that time. So some customers ask me if it's a live instance, what can I do? I cannot stop a production environment. So my suggestion is that in such case you can clone that environment to another environment. Every virtualization environment provides a cloning mechanism, so you could do that. So here is the one. I'm going to go and stop this application while the snapshot is taking place. See if the VM is stopped. Okay, the instance is stopped now, so now I can try to refresh the screen. So we could have done a little more better job here with respect to an automatic try, but then okay. All right, so you can see that the migration plan is created now, but honestly, there's still some more things to be done here. But you can go ahead and review the migration plan, and also you can see the generated artifacts. I need to make a change here is the data folder. So this is a user input that I need to give. So I need to give where my persistent volume will be mounted. So I'm giving a /data file system. So let's go ahead and save and generate the artifacts. It's in process now. It is actually live migrating, which means you don't have to worry about where your source is, even if it is in on-premise. And of course, you will have to establish the hybrid connectivity between the data center and the cloud. Assuming that we have that in place, it would automatically go ahead and create these images. It will push this image into a Docker registry. It will create Docker files relevant to your image that gets created. It will also create Kubernetes deployment manifest, which you can apply in a cluster. As you can see that the migration is complete now. All the artifacts are created. Let's go and review the artifacts also. So let's quickly review the artifacts created by N4A. So first of all, it has got a Docker file here. It has got a container image for deployment, also a base image, which is supplied by Google. It's got a deployment spec, which is of Kubernetes. These are the standard migration plans. Let's click on the Docker file. So you'll see that we have got a base image coming here from Google Cloud, and this is an example of a multi-stage build where we are also using a base image, which is the source image, which is time-stamped here, and we also have a provision for extending this Docker file should there be a need to patch or forward engineer your applications to deploy modify this base image, right? So that's the beauty of this solution, that this is not a static production environment to a Kubernetes deployment, but you can actually go ahead and make modification to the images as well. That's pretty much it. The entry point is a standard one, so this is the entry point that gets that basically runs in that environment. Now let's pick up the deployment for the replicas number one. So that means you can, if you want, you can scale these replicas to a number of stateful sets, and then that will all be load balanced, and that's how you can start using some of the cloud services. Like Google Cloud has a very strong offering in the form of GCLB, both for layer 4 and layer 7 connections. You'll see that it automatically created and pushed the image into a Docker registry. You will also see that there is the persistent volumes. If you see, I mentioned about this 10 GB disk earlier, so it gets converted to this persistent volume, and the persistent disk is now available to the Kubernetes cluster for consuming for the MySQL database. And using a persistent volume claim, and the rest of them are just the app deployment. So that's pretty much it. What we'll do is copy this content into, we'll fire up a browser to deploy this application. So one thing to note here is, from a services point of view, let's relook at the service. If you see, the service is just a cluster IP service, so it does not define an ingress or a load balancer to access this application. So this is a place where you can, depending on how you want to access the application, you can define either a service type load balancer or an access from the ingress using a kind ingress. All right, so let's go ahead and deploy the manifest to a Kubernetes cluster. So before I do that, I would like to actually get an access route or an entry point into the application via a load balancer. So like I said, when the tool converts this application, it puts headless service as cluster IP. So I'll go ahead and make one modification, that is by putting an access route via a layer 4 load balancer, which is going to go and hit at port number 80. So that is the only change that I have done. Now we will apply this to a Kubernetes cluster. So let's go ahead and apply deploy.yaml sn m4a. So I've got a namespace here by the name m4a, and that's it. Okay, looks like some of the components are created. We can review them, and we can in fact review the storage first. So pvc pv msc -nm4 demo. Okay, as you can see, the first thing to note here is that we have got a persistent volume claim, which is this one, which refers to a persistent volume, and I believe that should be the 10 GB disk that we earlier had. So this is that 10 GB disk. You can see that the disk is, the status is that it is already bound. That means everything that you can require from the data access is taken care, right? And I think these are all the system generated CRDs, which is basically supporting the Migrate for Anthos application. But for our application, we just need to look at the namespace to which we have deployed our PVCs. So it is here. Why I'm showing this one is that it is important to know that this migration tool is not just to migrate an application. This very well converts your data, which is in your VM, into the Kubernetes equivalent, which is a persistent volume, and then access it within your application using a claim. All right, so now let's look at the application itself, the services. So demo. Okay, so you can see here that there is an access route to the application, and also there is just one replica. As you can see here that we have one replica it's running. So I'm assuming that if I hit the URL, it should start working. All right, so let's go ahead and click and see if anything got converted. Awesome. As you can see here, the application is up and running exactly same. You don't see a difference at all. So that is cool. So let's go ahead and see a few more things. So the first thing that we might want to do is to scale this application. Now that we have moved a VM-based application to a Kubernetes-based application, So now you can start to benefit from the goodness of the platform, what it offers. And one of the things that it offers is an easy scalability. And let's go and see how you can scale this application very easily and very quickly. So I'll just open the editor again. All I need to do is just go and create the number of replica sets I have is 1. I'll just make it 3 and save it, come out and do a kubectl apply again. So apply, that's it. And we can now use maybe canines to review. It's more easy to review this with this visual tool. Now, as you can see here, the pods are coming up. Yeah, so there was 0, 1 and 2. You can see the container is getting created. It's already in running state now. So now you have scaled your application from one application to 3. How easy it was. And if you want to look for the logs, what we can do is we can go and hit, so we can see that the load balancer is indeed working fine. So we'll hit the application and let's come back, and we don't know where the logs are going, so we will randomly pick up one of them, let's say the first one, and review for the logs. Okay, looks like that request actually came to this particular container. We can try to hit it again and see if that is the case. Okay, maybe it is maybe the next request went to another pod, but anyway, so this is how you we can also review the workload and the entire environment from the Kubernetes UI on GKE. So you can, for the workloads, you can come here and you can see that we have we have an application deployed as a stateful set, and we had 3 replicas, and that you can see from here. I can click it here to look at a little bit more detail about the deployment, like your CPU, average CPU, memory and utilization of the application. And you can also see the logs, and okay, so you can see the logs, and this will all be aggregated because we do not know which container would be serving your request. So so that's pretty much it. Maybe one load balancer. Let me also show you the load balancer part. So we'll access it via the services and ingress because we have a layer 4. So you can see here that this is external load balancer here. But if I click on the load balancer, I can see this is, yeah, you can see the serving pods here. So these are the 3 serving pods behind that layer 4 load balancer. It's a pass-through load balancer, unlike layer 7 HTTP load balancer, which is a proxy load balancer. This is a network load balancer as a pass-through. So whatever packet comes onto this load balancer, it will just forward it or apply some algorithm to find which backend it has to send, and then it will just more like unintelligently send it out onto that particular node. So that is a great. There's a lot more things that you can see, that now you have migrated your application to a cloud native environment, and instead of breaking open your application, now you can start to gain from what the platform has to offer. For example, like how you saw that at some point in time you wanted to scale this application. How easy was it to scale and then put a very, very powerful cloud load balancer in front to distribute your load. So those kind of things. So that is what I was referring to earlier, that it's a trade-off. Would you like to go the route to go rewrite the application as a microservices architecture? That means break open your application and do that, or you would like to keep it as it is and start to get the benefit of the platform, so that you can fix your operational issues. You can get pretty good at your and then as a second pass, slowly you can migrate your application. You really want to make them as cloud native and the modern apps that I talked about earlier. So that's it. With this, I would like to end the demo. It was a great exercise for me as well, and I was very impressed with the fact that I did not need to make one line code change to to deploy or to migrate this application, which is not a simple application. It was a, in fact, it was a COTS application in some sense, right? It has got a PHP server and got a MySQL database and then a couple of other complex things going on inside. So that's it. Thank you very much for being with me on this demo, and I will see you next time with some other great demo. Thank you.